Today we discuss on air conditioning first. That air conditioning is a part of the Applied Thermodynamics course. Okay, but air conditioning as a whole, it is a subject. It is a course. You will perhaps come across some online courses, full course on air conditioning. Okay, there all these parts with individual components in details will be analyzed. But here air conditioning is a part of Applied Thermodynamics course, is a module only. Okay. So now basically, what is the meaning of air conditioning? We will try to understand that is whatever is most essential that we will study first. Okay, then we will try to study that means what are required for that. Okay, okay. So that means what is basically required first. What is the aim? What do you mean by air conditioning? You know air conditioning, right? So means air, atmospheric air, not atmospheric air. You will basically condition the space which you are living. You cannot condition the whole air, whole atmosphere. You cannot condition. So you will select a particular space. You will select a particular space, and within that space you will try to control the air. Condition of the air you will control. Okay. तुम मतलब प्रॉपर्ली फॉलो करो तो मेरा फोकस करो मतलब रिकॉर्डिंग होना ठीक है तो what we are basically trying to see is the conditioning of air. Now it can be also meaning, it can also mean that we are trying to control the condition of air. So here you see that we are feeling not comfortable. In this space we are not feeling comfortable. If the temperature rises, that time also we will not feel comfortable. Why? Because that there is a comfortable zone. Beyond that, that is not that human condition. That means human comfort is having a particular zone, and beyond that, either it is too cold or it is too hot, is not comfortable. So we want to control the environment within which we are living, not outside. So we will take a select space in which we will basically control the condition. Okay? Okay. So controlling in a small region, say. Small region. It's not. We are not going to not the entire environment. Okay? So we cannot control that because it is beyond our means it is not in our scope. Right? You cannot control the whole globe. The temperature is rising, you cannot control it. That is not in our range or scope. So we will have a particular space. Maybe it is a room, maybe it is a building, maybe it is a small room, maybe it is a building, full building. Say maybe it is a room or building. Or maybe it's a very small space. So some electronic equipments need to be very running very precisely, and for that temperature need to be precise. Right? So for example, the towers for mobiles communications, they need to be precisely controlled. The temperature need to be precisely controlled. Okay. So those are required. Those require the temperature control. Now here, controlling means basically there will be three things that we will control. So controlling of the condition, conditions which we will control. What we will control. So controlling of temperature. Next, any idea?
Humidity.
Humidity. We will see that both these have many variations. Like temperature, we will use equal temperature. We will see that there are many such variations of temperature. Immediately, now we will see that in air conditioning, at least there are four temperatures, four types of temperatures. Okay. Humidity, there are two types of humidity. And three, there is, see, that temperature. Say for example, you told rightly, temperature, you have to say for example, now it is say how much? Any idea?
25.
Now?
अभी तो 45 पे आता है.
नहीं 45 नहीं. Let's guess. Here it will be about now it will be about 35, 37, 35 or 37.
40. 40.
मोबाइल में क्या है? मोबाइल में तो थोड़ा बहुत दिखा रहा है. फुल. Let me see. What is the temperature? You see how much it is? 32.
Yes, sir.
Isn't it? So it is 32. So it's 32. Okay. But it is feeling like 40 about like so there is a trend. Say temperature is 32 but feeling like 40. Why?
Due to humidity.
Exactly. So we will see there is humidity. We will see. So 32 is the temperature. This is one temperature. That I told that there will be four such temperatures. This is one of them. This temperature is one of them, which we directly measure. This temperature is one of them. There are other three temperatures. Okay. Next is you see that how do we count the point one by one. Temperature. You need to say for example bring it down. Humidity. You will need to bring it down to a particular level. Okay. If it is too less, then also it is not good. You will feel dryness. And if it is too more, then also you will feel sweating. Right? So it should be temperature is said to be about 25 degree Celsius. Comfortable, human comfort. Humidity is there are two humidities. One is called specific humidity, another is called relative humidity. We will see. So relative humidity we call it RH. RH, relative humidity. It is about 50%. Okay, comfortable. And there is another condition which is required is
fan speed.
The fan speed. Or here actually not fan speed, we call it the air motion. The flow of air or the air motion, air speed. Okay. exactly recall the value. I think it's about. I will confirm it later. Okay. Exactly. So there is a value of about say 25 meter per second like that. Okay. I will confirm it exactly. 25 meter per second. Okay. Now, so these things are to be controlled. So one by one we will see. Now, what is the air? So what is air?
Mixture of gases.
Right. Yeah. Yeah, definitely. It's a mixture of gases. You are right. Now, what are the gases? We will actually define air as a mixture of two things. One is we will call dry air. Dry air. So it's a mixture of dry air. Dry air means basically what? O2, N2, some carbon, some fluid. Okay. Next, the mixture of dry air and another very important thing, moisture. So, moisture. Okay. So, it's a mixture of dry air and moisture. So, this air is called atmospheric air. This actual air, we call it atmospheric air. So, atmospheric air is a mixture of dry air and moisture or water vapor. Okay. So, we call it basically atmospheric air or moist air. Or moist air. So moist air or atmospheric air is equal to dry air plus water vapor or moisture. Okay. Now one thing we have to understand clearly that the amount of this is not going to change. In air, whatever we do in the name of conditioning, we are not going to change this. We are only changing temperature, humidity, and airspeed or whatever. But this amount will not change. Okay. So the amount of this is fixed. The amount of this is fixed. Let us start. Amount as well as composition. They are not going to change. This dry air is amount, that means quantity as well as quality wise, that will not change. Okay, so we are going to change only the moisture. Either we will add moisture or we will extract moisture. There are two names for this. One is called humidification, another is called dehumidification. Two names are there, we will see them. Okay, so dry air and water vapor. Now we will see one thing that what is the temperature almost in the atmosphere? What is the temperature? Say about say 10 degrees centigrade to about say 50 degrees centigrade. Atmospheric temperature. Say 10 degrees centigrade to 50 degrees centigrade. Or say for example in winter countries. So it is say about say from minus 10, 20 to say 40, 50. Right? So in this zone of temperature, this is already ideal gas. Dry air is ideal gas. But we will see that water vapor also will behave like ideal gas. In this temperature, it is not for all temperatures. Okay. In this temperature, the moisture or the water vapor will be acting as basically ideal gas. Like if I draw the diagram, TS diagram of water. So this is T entropy. So it is like this. Now the temperature is like here. It is how much? 374.14 degrees centigrade. Triple point is how much? 0.01 degrees centigrade. So 50 is about here. 50 is about here. Say 0 to say 50 if I draw. It is like within this. This is the band of population. What air conditioning we will do? We will operate within this zone. And we will see beautifully that the observation is that the constant enthalpy lines, this is a constant enthalpy line. Say, constant enthalpy line is constant temperature line. Exactly. Constant enthalpy lines will be horizontal in this zone. So what is the meaning? Meaning is that this enthalpy is a constant enthalpy line. This enthalpy H is a function of temperature only. This enthalpy is a function of temperature only. Right? That is true for ideal gas. For ideal gas also we know that enthalpy is a function of temperature only. So this behaves like ideal gas. In this zone, that means here in this zone the moisture or water vapor will act like ideal gas. This is one thing. Now we will see another thing, very important thing. One by one you will try to understand. Another thing is that what is the state of moisture in the atmosphere? In the atmosphere, what is the state of water vapor? In which state it is actually present? Is it water? Or is liquid condition? Or saturated vapor? Is it liquid? Or saturated vapor or superheated vapor?
So liquid.
Do you find any liquid? Can you catch any liquid? Can you catch any liquid? No. Water vapor, but you will see that it is non-liquid, but you will see that this is existing as actually superheated vapor. So in the atmosphere, the moisture is existing as superheated vapor, not even saturated vapor. That will be saturated vapor only when the atmosphere is saturated with moisture. During dew formation, that means during dew formation, when the dew is formed at the night, at that time it is saturated with moisture. Only in the vicinity of the land. Only at the vicinity of the land, not everywhere. That you have to clearly understand. Only at the vicinity of the land, very close to the land, because the land gets cooled moisture exists as superheated vapor. So this moisture exists as superheated. This is one important thing to understand. Okay, we can prove it. Obviously, we can prove it. Now, now we will go to the quantity calculation. So, we know that atmospheric air or moist air is basically is combination of dry air and water. Therefore, if I consider a particular space, then total pressure of this total zone is filled by both the dry air and moisture. So the volume is same for both. Therefore, from the law of partial pressure, right? Dalton's law of partial pressure. Then what is that? What is that? Total pressure is equal to pressure dry air pressure of vapor. So this is total pressure, and this is the total pressure is equal to dry air pressure plus water vapor pressure. So this is from the Dalton's law of partial pressure. What is that? Partial pressure means if I allow only dry air. What is the meaning of that? What is the meaning of partial pressure? This is the partial pressure. This is basically what? Partial pressure of dry air, and this is partial pressure of water vapor. Okay, so what is the meaning? Say for example, the volume of this space is say V. Volume of this space is say V. Okay, so volume is say V. Now, if I, so here what is the constituent? Dry air plus water. Now, within this total volume, if I allow only dry air at the same temperature, what is the temperature of dry air and water vapor in this room? Same. Both are having the same temperature, they are sharing the same temperature and same volume. Only the pressures are actually having, I consider what is the meaning of partial pressure? Partial pressure means basically if I allow the dry air to be only within this zone, and if I remove the vapor from this room, the dry air will be actually filling the whole room, and the pressure exerted by that is the partial pressure. Clear? Similarly, if I remove dry air from the room and allow only the water vapor to exist in the room, then within this total volume V and the total at the same temperature T, if the water vapor is allowed to exist within the room, then the pressure exerted by the vapor is the partial pressure of the vapor. So, total pressure of the room is equal to the partial pressure of the dry air and the partial pressure of the water vapor. Clear? Similarly, there is another concept that is called Amaker's law of partial volume. Amaker's law of partial volume. So that is meaning is that if the temperature and pressure of both are same, then the volume will be one will be VA and another will be VB. So partial volume, the law of partial volume. Although that will not be required much here, law of partial volume is total volume is equal to VA plus VB. Meaning is that if the dry air, if the dry air only is allowed to be in this in a particular space, but the pressure is P and the temperature is T. So here at P and T, that means the condition of the volume is that this is situated, this is existing at the condition of total pressure and total temperature. So the volume will be definitely less. Volume will be less because, for example, if you have small amount of mass, then if you are having the same pressure, then the volume should be less. It will be actually occupying a less space to exert the same pressure. Isn't it? Say for example, in the atmosphere, say for example, the moisture is 1%. Moisture is 1% by volume. Moisture is existing as 1% by volume. So 1% moisture and 99% dry air by volume. Say. So if that 1% is allowed to exert the same pressure, definitely the volume will be less. Isn't it? So 1% is allowed to exert the same pressure. So it will add the same pressure. So it cannot be occupying a large space. So if it is occupying a large space, then the pressure will reduce. The vacuum will be created. So that small volume, the small fraction of volume is now occupying a less space to exert the same pressure at the same temperature. Clear or not? So that is partial law of partial volume and law of partial volume. Although this will not be required much for this. Okay, but this will be Dalton's law of partial pressure. Here partial pressure clear. So there will be basically two pressure conditions. One is the partial pressure of dry air, another is the partial pressure of moisture. Okay. Now, therefore, how to know that what is the state of the moisture in this room? To know the temperature and pressure. To know the temperature and pressure. Now, what is the how to identify the state here? The pressure that we will identify here, it will be which pressure? Is it total pressure or the vapor pressure? Here, say for example in the TS diagram, if I try to identify a constant pressure process, okay, which pressure we will select? Total pressure or vapor pressure?
Total pressure.
This is the, say for example, this is the pressure of what? This is the diagram of what?
Moisture.
Moisture. Now you consider, always try to think that, say for example, if you have a container in which you have water, you have done experiments, at least thought experiment in thermodynamics 1. Say you have some water, you are boiling it, right? So in the container, there is only air, there is only water, or water vapor, liquid and vapor. There is no air. So whatever pressure is exerted, that is due to water only, either in the liquid form or in the vapor form. There is no air. Okay. So maybe it is open. I will explain why it is like that. Even if it is open, what will happen initially? You see that if I apply a flame here, say if I apply a flame here, and if it is heated, what will happen initially? Initially there will be air here. Then there will be air, obviously. There will be air. Now, from the surface you know that there will be evaporation. Water vapor will be generated. Initially there was air. So total pressure here in the bucket or in pot. In the pot there is water, but above that there is air, and in the air there is moisture. Definitely, therefore, the pressure here will be total pressure. Definitely. If we have closed it and remove the air, then only there will be only the water, the pressure due to water. But if it is open, then there will be the atmospheric air and the pressure will be due to both dry air and water vapor. Here. So the pressure that is exerted on the water surface, the molecule of the water surface is due to dry air and moisture both. Now what will happen? As you heat it more and more, so what will happen? Moistures will be generated more and more. So in the vicinity of the water surface, initially the humidity amount was less before heating. Now as you heat, what will happen? More and more moisture will be generated. So that space will be occupied by more and more moistures. So the fraction of moisture will increase. As the fraction of moisture increases, this will increase and this will proportionately decrease. So as you heat more and more, what will happen? When the boiling will start basically. What we call boiling? Boiling means basically here the moisture is so much that the pressure from this side and pressure from that side they are equal. Okay, and the boiling will start. Okay, so therefore the pressure there will be no air here and it will be fully occupied by moisture. Here in this zone it will be fully occupied by moisture and therefore total pressure will be due to vapor only. So the dry air will be removed. The vapor will come out and it will expel the dry air. So the total pressure here will be due to vapor pressure. Therefore, your answer, that is, it is total pressure, it is correct. But there is no dry air. Only thing is that vapor has come and it has expelled the water. Air. So the total will be here, will be water vapor. Okay, clear? Now, you see that here, whatever pressure we are trying to understand, that pressure is due to this pressure. But for boiling, it is same as this. But here there is no boiling. Atmosphere में तो boiling नहीं हो रहा है अभी. हम लोग तो मर जाते हैं. ठीक है ना? तो यहाँ पर boiling नहीं हो रहा है. ठीक है? तो क्या हो रहा है? जो भी हो रहा है कुछ. So that pressure here, that means whatever pressure we are trying to understand or whatever pressure we are trying to plot in the phase diagram, that is the pressure of moisture. So that is the pressure of this. So this diagram will contain only pressure. This one. For boiling, this is the total pressure, but otherwise this is partial pressure. Okay. Now, in this case, say for example, if it is 1%, say, if it is 1% by volume, then I can calculate what is the partial pressure. So, for example, 100 kilopascal है atmospheric pressure, 100 kilopascal, 101 kilopascal. 101.325 at 1 atmosphere. तो partial pressure of vapor कितना हो जाएगा 1 kilopascal around. So from the same table you can see that what is the condition of steam at 1 kilopascal and say for example 32 degrees Celsius. You will see that this is superheated vapor. Definitely it will be superheated. So this is a superheated. You can think immediately. You can see that what is the saturation temperature at 1 kilopascal. You will see that it is much less than 30. Therefore, it will be superheated. That means in the atmosphere, although it is superheated vapor, but we are not getting burned because the temperature is less and the pressure is much less. So in this less temperature also it is superheated vapor because the vapor pressure is less. Vapor pressure is less, that is why we are not feeling burned. Even if existing at superheated vapor. We are comfortable within the superheated vapor, but we are not feeling because the pressure is much less, so it is not the temperature is that is why the temperature is also less. Clear? So that part is clear. So in this zone, the atmospheric condition is superheated vapor and this is ideal gas. So that was the point to discuss. So say for example, in this zone it is operating and it is ideal gas. And the dry air is already ideal gas. There is no problem. Dry air is already ideal gas. Okay, so therefore the laws of ideal gas will be applicable. We can apply the law of ideal gas for this. Okay. So for moisture, okay. Now for moisture, there will be basically certain quantities. So we will call one quantity as specific humidity. Specific humidity. What is that? Symbol is omega or small w like that. Specific humidity means basically the mass of water vapor divided by the mass of dry vapor. Okay, mass of water vapor divided by the mass of dry air. Now, what is the meaning? That is, although it appears to be unitless, okay, but we specify a unit. Say, for example, if we specify this with kg and this also with kg, then kg and kg will cancel. But we specify this with gram and this with kg, so that it makes a unit for this. We call it this much of gram of moisture, or specific humidity is this much of gram per kg of dry air. So 1 kg में कितना moisture है, 1 kg dry air में कितना moisture है, इसी से हमको इसको specify करना है. Specific humidity. This we also call as humidity ratio. The same thing, another name for this is humidity ratio. Okay. Now, we will try to understand what is the meaning of this. Omega is equal to mass of water vapor, say mass of water vapor by mass of dry air. Like that. Now, say for example, if we write ideal gas equation of state, ideal gas. So we know that P. What is the formation here? For the whole room, the pressures are different. The volumes are same. Okay, you may take it by unit volume, but the volumes for both are same, dry air and moisture. They are occupying the same volume, but sharing the same temperature, but having different pressures. Partial pressures will be different. Okay, so therefore P V dV is equal to, I'm sorry, P V into total volume is equal to mv RV RV means the characteristic gas constant for water, and P is same for both. And therefore you can write what is, in terms of, if I write in terms of the universal gas constant, that also I can do. So what is that? We know that R W, R W will write, or R V will write. R V into molecular weight of water is equal to RU, isn't it? Therefore, RU is equal to, sorry, that means it will be basically, therefore RV is equal to RU by MV. So I can write that MV is equal to PV by RV. RV is equal to again RU by MV. So PV, then there it will be V and it is T. Isn't it? Simply I have just rearranged. So MV is equal to PV by RTM. Okay. Similarly, what is for dry air? MA, RA, sharing the same temperature. This is MA is equal, because we want to calculate this in terms of partial pressure. In terms of partial pressure, the ratio temperature and volume will cancel. They will be the same numerator, they will cancel. Only partial pressures will remain. So it will be PA V by RU. RU also will cancel because universal same for both. And clear? Yeah. Therefore, what is this? If I divide this two, which will cancel? This will cancel V R. This will cancel. Okay. So it will be MV is equal to PV. So this is PV. A is equal to PV so RU, RV, so RU by M, PV, MV by PA, AV. Right? So what is that? Now that you see that this is fixed quantity, this is fixed quantity. Molecular weight of dry air and molecular weight of moisture, these are known. So molecular weight of dry air, AV, during our discussion on combustion, we have seen what is that? About 28.97. What is the unit? kg per kilogram. And molecular weight of moisture, how much is that? 18 kg per kilogram. So therefore is Babu?
Specific.
P3 by PA and AB by AB. How much is this? 18 by 28. 18 by 29 about that. About 0.622 ऐसा है ना ऐसा नहीं 18 by that 18 by that
What is